This demonstration will show how to implement a Spatial Data Infrastructure, or SDI, for disaster response. A spatial data infrastructure stands as a central pillar in the disaster lifecycle, supporting emergency response managers as they craft a response strategy for emergency responders. This will be demonstrated with the National Geo Platform and the SOF4D application. The scenario today centers around frequent flooding disasters in Ghana, Africa. Seasonal floods are a recurring problem for Ghana, affecting suburban communities and displacing civilians from their homes. In this scenario, a flood has submerged suburbs of Accra, Ghana's capital. Multiple civilians have been trapped in the floodwaters and require rescue. The emergency response manager is going to assess the situation, identify hazards, and craft a strategy through integrated data that will be sent to the emergency responders before the disaster escalates further. First, the emergency response manager is going to collect relevant data on the affected area. This will be done using a national SDI, a system of geospatial data, metadata, users, and tools that work in an interoperable structure. The National Geo Platform, a Federal Geographic Data Committee initiative, is the U.S. national SDI that aggregates, indexes, links, and organizes web resources into a collection of curated objects, the Geo Platform portfolio. Using this collection of geospatial assets, the emergency manager will find the data to tell responders on the ground where they need to focus efforts. The emergency response manager is looking for informative data in the Geo Platform by using the Semantic Search feature. Semantic Search enables data providers and data users to ground their data in commonly recognized vocabularies. They'll be searching for data in the FEMA MODI vocabulary, which is derived from classifications from FEMA's database of assets on the web. Using these semantic concepts, the emergency manager can find resources that match his needs for this scenario. Using Semantic Search, he's going to focus on the host of key terms contained in the vocabulary: response, flash flood hazard, mass search and rescue operations, situational assessment, emergency support function 9, search and rescue, topography, inundation, and Ghana. Any items semantically linked to these concepts will show up in the query. Some useful services such as topographic data, flood models, and road mapping are already showing up and can be combined to create a situational assessment. The emergency manager can determine what layers he wants from these services and view them in Geo Platform's web application, Map Viewer, to confirm their relevance to the current mission. One thing he finds is that topography and reported flood levels have created areas where rescue workers will only be able to reach civilians via boats, an important piece of information that he'll be sure to communicate to the first responders. Having found the layers the emergency manager wants to use for a response strategy, he's going to use the interoperable capabilities of this architecture. Pivoting to SOF4D, the manager will integrate the layers with augmented reality info aids to help responders follow the strategy. SOF4D imports any OGC standard open web service, allowing him to assign those layers to the mission. Here he can create mission-specific operating pictures, or MSOPs, which have specific tasking for the emergency response. Here there are some pre-rendered MSOPs which point out key information to first responders. Correct iconography is important to communication, and this manager is employing the native symbol library icon set for this scenario. He will tag the flood extents, the civilian locations, and the best routes to reach them with an info aid so first responders know what their objectives are. Each MSOP can now be captured in a Geo Package, which can be pulled to a mobile platform by the first responders. The value of Geo Package is its ability to be generated from authoritative and curated sources for deployment to a variety of platforms including web, desktop, and mobile devices. Some new information has arrived. Crowdsourced data has informed the manager about a family trapped deeper in the floodwater zone. He's going to tag this information in an MSOP and deploy it as a Geo Package. On the ground, first responders are now seeing the augmented reality view of SOF4D on a mobile platform. Through the use of the info aids, they can see the instructions laid out by the emergency manager. Through the use of navigation markers, they can clearly see the info aids for the recommended path and their intended destination. They can also capture pictures and push it out to the rest of the team so they can be aware of the situation on the ground. Following these instructions, first responders quickly rescue civilians from being trapped in the flood zone. Through the use of open web services and an interoperable architecture, the emergency response manager has crafted a fast response to a flood scenario. Good data management and curation is the key to supporting a national SDI. Make sure that metadata is robust and semantically tagged so that it's accessible to everyone. Through the use of a national SDI, emergency responders can find the data they need faster and apply it to interoperable tools so that the tough questions can be answered quickly.